Okay, for this one, we want to analyze the graph by finding this information, then we'll draw the graph. Okay, so first we need to find the zeros. To find the zeros, you just look for what makes each individual part equal to 0. So the first part, if you take that whole term, negative 2x cubed, set it equal to 0, you'll get 0. So that would be the first one. Next, what makes this part 0? Okay, x plus 2 equals 0, that means that negative 2 is going to be your answer. That's your x-intercept there. Multiplicities, you're looking for the powers that are on each of the factored pieces. So for this first part, we don't have any sets of parentheses, but we do have an x there, and you are going to look at the power on that x. That's a 3 in this case, which means that the 0 is going to have a multiplicity of 3. The second piece has a 1 on the parentheses. That means that factored piece, the multiplicity is going to be 1. The y-intercept. Y-intercept is where you have x is equal to 0. If you put a 0 in here, it's going to get 0 for the entire thing. So therefore, 0 in for x will give you a 0. The y-intercept is going to be 0. So that means that we actually get it going through the point 0, 0 is where it'll cross through. That 0, 0 is a x and a y-intercept at the same time. If you add these together, if you add the multiplicities together, you're going to always end up with the degree. Degree is equal to the sum of the multiplicities, so we get 4. Since we have this, we know the max number of turning points will be 1 less than that, which means that the maximum turning points is going to be 3. Next, we want to find the behaviors. This is what the graph looks like as you cross each of those x-intercepts there. So first we have a 0 at, a behavior at 0. That's the first one we're going to look at. What you do for these behaviors, you put 0 into every piece that does not give you a 0 for the whole thing. So if you put 0 in the first one, that's not going to work because the whole thing will cancel out. So we want to leave that one alone, leave that as just x cubed, and we'll put a 0 into the second one. So you get y equals negative 2x cubed, we leave that alone, and then we put it in here and we get 0 plus 2, and then when we simplify it, we end up with negative 4x cubed. So this is negative 4x cubed right here. That's my behavior expression for that one. Okay, so what does that look like? Okay, I have x cubed. So a cube normally would be the graph that kind of looks like this. It has a wavy line in it. However, we have a negative sign in front. So negative, remember from transformations, that's where you'll take the graph and you flip it this way over the y-axis. So actually the graph is going to have to look like this. Normally it would go the other direction, but the negative sign here actually flips that, and so the graph itself is going to resemble this one like that. So when it crosses at 0, the graph will resemble this shape. Next, I want to find the behavior at negative 2. So at negative 2 is going to go into the first one, but I don't want to put negative 2 in this one because otherwise the whole thing's going to cancel out and I'll get a 0. Negative 2 will go into the first one. So I have negative 2 will go into the first x right there, and then I'm not going to put anything in the second one because otherwise everything will cancel out. I want to leave that as just an x. Okay, so now I'm going to simplify it. That gives me negative 8 times negative 2, that's positive 16. And I end up with actually a line. If I multiply that out, I get 16x minus 32. That's a line that has a positive slope, which means it's going to resemble this one to be a line slanting to the right. Anytime you have a positive slope, it slants to the right. Negative slopes will slant to the left. Okay, and the last thing we want to find now before we do the graph is we're going to do end behavior. So end behavior is what the graph looks like on each end. So end behavior, I'll do that first, then I'll put all the information together on the graph. Okay, so end behavior, you need to know if the degree is odd or even, and also you need to know what that a of n value is. Okay, so for this one, your degree is even because the degree is 4. So degree is even. And the a of n again, if I were to multiply this out, that would be the number in front of the term that has the highest power. If I multiply the first thing together here, I would get negative 2x to the 4th. So the negative 2 here, that would be considered your a of n. That's the number in front of the term that has the highest power. Again, I don't really care about the actual number itself. I'm only concerned about is it greater than 0 or less than 0. In this case, it's going to be less than 0 because you have a negative 2 there. Okay, so if it's less than 0, that means that the model, it's going to do this. It's going to go down and then go down there. Both of them actually end up pointing down. So when I draw in everything, I know I'm going to go through the origin, 0, 0. It also goes through negative 2. When you're at 0, the behavior is going to resemble this shape. It's going to look like a negative cube graph. So I'm going to draw that in. So if you're doing this on assignments or a test, make sure you make it clear that there really is a bend in the graph there. Because sometimes if you don't draw it right, it may look like a line and then it might be misinterpreted as a wrong answer. So you want to make sure that you kind of highlight it and kind of exaggerate that it's actually going to be a wave in the graph. There's a bend in the graph right there when it goes through at 0, 0. Okay, now the other one is a line, and that negative 2, that's a line that is going to look like this. And then my end behavior, it's going to go down and it's going to go down. So now I have almost the whole graph complete. I'm just going to connect it. So to go here, this will go up to a certain point. Again, exactly how high it goes up to, we're not really sure unless we plot points. We're just doing a general sketch. So in this case, this is what your graph will look like. It'll go up here, it'll turn, we have a bend in the graph, and then both ends end up going down.